Sniffing is one of the most important tools or techniques that you can master in your penetration testing career. It all comes down to protocol analysis at the end of the day. So let's look at a few of the concepts here. First major picture here is there are hardware sniffers and then there are software sniffers. Most of the ones that we're going to cover are going to be software based, although there are a variety of hardware-based sniffers or protocol analyzers which can be used ultimately to profile or enumerate information on traffic. Second major concept. An organization realistically has to choose which route that they're going to go in terms of accessing the network. So they could use a hub, which is a little bit outdated of a technique, but nonetheless everybody can hear each other on a hub. Or they can set up span or switch port analysis. This is basically port duplicating. So between a source and a destination, the span port is configured to listen to that source and destination and then mirror that traffic to a listening port. Or they can use some sort of hardware tap, which can be relatively expensive. So the larger the organization, you increase the likelihood of them actually using network taps. The smaller the organization, this is where they start using hubs and span ports, where span ports are, I would suggest, are basically the norm. Also, you have to be a master at the TCP/IP protocol stack, both version 4 and version 6. Next concept is the concept of a promiscuous mode interface. Now, if you've ever installed something like Wireshark, you're going to get prompted for an additional piece of software to get installed, which basically allows your network adapter to be used as a sniffing interface. So if you think about it in terms of sending and receiving, now you can receive everybody else's traffic on the network. And then, of course, there's the concepts of hubs versus switching. Hubs, everybody hears everybody on a hub. So it's literally a very loud, contentious type of device. Where on a switch, only the source and destination actually hear each other. So if port A wants to or if port 1 wants to talk to port 2, port 3, 4, and 5, or the rest of the ports, they don't hear that. So that introduces the concept of a collision domain. However, anybody that broadcasts out any sort of traffic, whether it be DHCP or name resolution or whatever it is, everybody's going to hear everybody on both a hub and a switch for broadcast-based traffic. Now, routers, on the other hand, they will not forward broadcast because routers, they contain the broadcast domain. Also, the major concept here is protocols. When you're sniffing traffic, you actually get to see these protocols in work. So if you want to learn how DNS works, sniff DNS traffic. If you want to learn how DHCP works, sniff DNS traffic. This literally will do wonders for your career in terms of actually understanding how the behavior of the different protocols work. Okay? Next, let's go into threats. Now, the major threat here is disclosure. Now, if we kind of look at this from a principle-based point of view, you basically have integrity and confidentiality in play. But disclosure is the obvious one because you're listening to somebody else's traffic, but that disclosure can lead to like a man-in-the-middle attack, which ultimately could change the integrity of the network traffic. Also, the threats. Now, you can summarize most of this into whatever protocol is in play. For example, DNS, or email like SMTP, or POP3, or IMAP, or web traffic, or chat, or file transfer protocols, or even router updates, or telnet traffic, if anybody's even still using that. Nonetheless, you can summarize all of that in clear text. Anything that is in clear text has the ability to be listened to. And that's where sniffing comes in play. So it doesn't matter if it's syslog traffic or web traffic or email. If it's in clear text, you can read the exact traffic that's on the network. Therefore, the holy grail becomes passwords. If you're sniffing traffic and you can get a username and password and dig that out of a data field, that's it. Now you can access that system. And you'd be surprised how many passwords are encrypted in the application, but as soon as that application talks to another application, they actually send the passwords in clear text. Next, we can move over to wiretapping, because that leads us to the different types of attacks that ultimately will take place. So MAC spoofing. Spoofing meaning we take over somebody else's MAC address, or we can manipulate the ARP process. Or if it's DHCP related, we could perhaps grab all of the available DHCP addresses from the DHCP server, therefore doing an attack on availability, and legitimate users can't get a DHCP address. Or ARP spoofing, pretending to be somebody else. This is where we can trick switches to sending a copy of somebody else's traffic to us. Or MAC duplicating. If we can listen to ARP requests, we can learn a MAC address, well, then we can use that in a duplication attempt. A good countermeasure to that is locking down your switch ports. Or ultimately, another attack on availability, MAC flooding. There's a couple great tools like MACoff and Yersinia, which are very, very easy to use, that flood the network with 151,000 floods per minute of just bogus traffic. So if you look at this from a principle-based point of view, disclosure is obvious here, but also you can be vulnerable to an integrity attack or even an availability attack as well. And then we can start going into some of the protocol specifics. For example, if you're sniffing DHCP traffic, then you can learn about how DHCP works, and you can see when does a particular computer do a DHCP discover or offer or request or things like that. All of the details of DHCP. You can do MAC and ARP analysis. Now this is realistically learning about how CAM tables work. Well, the easiest way to get this is from a switch's point of view. When a computer advertises through a switch, the switch will look at the source, analyze the MAC address in play, and then record that address and map that to a particular port. And then when the reply comes back from the other computer, you will get that reply as well, and it kind of builds its own table. Well, that's how things normally are supposed to work. Well, hackers have learned over the years to manipulate that process so that, for example, when a piece of traffic gets advertised to host C on a network, please send another copy of that to host D. So therefore, disclosure ultimately happens. Then you can go into DNS. DNS is its own subject matter, but you can learn lots about hosts. Remember, DNS has our whole name and mapping table, so if you can get physical access to a network and just filter basically DNS, well, you can learn a lot about the way that network is configured. Everything from Active Directory to web servers to mail servers, etc. So, some of the tools that are absolute critical for you to walk away from this sniffing concept with was absolutely, without a doubt, Wireshark. You must know Wireshark and how to do all of the filters. Now, the cool part about Wireshark is that the fields actually change from red to green. So if you got the right filter in the right exact format, it'll be green. Green for go, red for no. So if you mistype your filter, it won't let you actually get any results from that. Next is T-Shark, which is a terminal piece for Wireshark, so it just displays everything from the command prompt, if you will. Or WinDump or TCP dump. These are absolutely critical from a network analysis point of view, because firewall engineers, network engineers, system administrators, they realistically should know at least the basics of TCP dump. But hackers have also learned TCP flow, which separates traffic into different files. So that helps you isolate what goes on a network and then really focus on one particular host. So we talked about concepts, we talked about the threats, we talked about the different protocols and the tools that are in play. Let's look at some of the countermeasures. So since the obvious attack here is on confidentiality, well, encryption is going to, from a defensive point of view, encryption in any way, shape, or form is going to be your best friend. It doesn't matter if it's protocol encryption like HTTPS or SMTP or anything combined with SSL or TLS, or any application layer encryption, that's going to help you out a lot defensively. It also makes the penetration testers' job a lot more difficult because instead of getting plain text, now they're getting ciphertext, and that means they have to crack encryption just to be able to get the juicy stuff. Lockdown physical access. This is by far one of the easiest things to do to prevent the penetration tester from getting access to your network. However, it's typically a system administration headache. Okay, so in very large enterprises where they have CCNAs and CCNPs or professional network engineers working there, locking down the ports is pretty much common network practice. But in a mom and pop shop, it more or less never happens. So it really depends on the size of the organization. Also, MAC address assigning. For example, if you have a MAC address for a default gateway, every client that's using that default gateway should have that MAC address hard-coded. That way, the penetration tester can't insert him or herself into the middle of that conversation by advertising, hey, I'm the default gateway, send the traffic to me, and I'll forward it to the real default gateway. So if you actually assign that, that defeats a lot of the replay and the man-in-the-middle style attacks. Also, static MAC address entries or anything static, that means that the network administrator is actually assigning the stuff, and that's huge because that restricts the penetration tester and what they can do and how they can manipulate the different types of traffic. Also, what are you doing with IP version 4 versus version 6? Are you encrypting your traffic? Are you protecting it? Are you authenticating your sources? If you're only monitoring and you only have IP version 4 intrusion detection, but the network is also speaking IP version 6, well, I'm also going to sniff IPv6 traffic in addition to IPv4 traffic. And for that matter, any other protocol traffic like NWLink or IXBX, IPX, SPX, or NetBUI, or whatever the other protocol is, or whatever the other communication protocol is. Also, tunneling. If you from a defensive point of view, if you encapsulate your traffic in another protocol like GRE or layer 2 forwarding or PPTP or layer 2 tunneling protocol, that restricts, at least from the outside of the protocol, what I can see. Also, ICMP tunneling, HTTP tunneling, those are good countermeasures because it makes the penetration tester work that much harder. Also, the concept of least privilege, or COLP, just to make easy notes here. Concept of least privilege is huge because you're not going to give anybody on the network any additional access to something that they don't require. So you only give access to people to what they need and no more. That really makes the penetration tester's job difficult. Also, one-time passwords or one-time pads. Because even if I can sniff a password, if it's only used one time, well, then realistically, even though I've captured it, it's useless. Also, encryption, SSH, or anything that is wrapped by SSL or TLS, because when I'm sniffing the traffic, the only thing that I realistically get to see is the outside encryption layer. I don't get to see the actual protocols in work. All right, so those are the most common countermeasures. We've talked about the potential threats. We've talked about the most common things that we go after, DNS, MAC and ARP responses, DHCP, because you can learn about the different hosts on the network. The basic concepts of wiretapping and concepts in general. But when we do the hands-on examples, we're actually going to be focusing on tools like Wireshark, T-Shark, TCP dump, TCP flow, and things like that. These are going to be absolutely critical for the penetration tester to absolutely master. Now, in all of my experience in penetration testing, I can chalk a lot of it up to just spending a lot of time doing hands-on and analyzing network traffic. The more I listen to traffic, the more I understand how things are supposed to work, and you'd be surprised what you would find if it's in clear text. So with that, let's go ahead and look at some of the hands-on tools.